Now, let's move on to the discussion of hyperconjugation structure of many reactive species. So, let's start with the free radical. So, let me start with the tertiary radical. So, this is connected to CH3, then you have a CH3 here, then you have a CH3 here. So, this is tertiary radical, tertiary butyl radical, then you could have CH3, C, CH3 and then an H over here. And one radical. This is the secondary radical, and then you could have something like CH3 CH2 radical. So now let's try to see the structure of one among these, and then let's see how many structures are possible. So let's start ethyl free radical. So you have CH3 CH2 dot. I'm going to write this as C with a hydrogen, with a hydrogen, with a hydrogen, and then you have CH2 radical. So now what exactly is going to happen here? So this would undergo homolytic fission. One electron would shift here, one electron would shift here, and these two electrons would form a bond. So I would get the first hyperconjugation structure, which is HCH, and then I would be having a double bond CH2, and hydrogen would be left with one electron. Okay. Now, what exactly is going to happen in the second resonating structure? So, in the second hyperconjugation structure, this bond would undergo homolytic fission. So, these two electrons would be forming a bond. So, I would have something like H, then this is connected to C, CH2, and then there is one H here, there is one H here. And what exactly is going to happen is there could be a radical sign over here. Now, this would undergo homolytic fission, one electron shifts here, one electron shifts here. So, two electrons would be forming a bond, and I would get the third hyperconjugation structure. So, I'll be getting something like H, C, H, double bond CH2, right. Now, there would be a hydrogen radical over here, correct. So, this is basically the hyperconjugation effect. So, if you could see 3 alpha hydrogens, so that means you have got 3 hyperconjugation structures. Okay, so 3 hyperconjugation structure, so 3 alpha hydrogen. So if you could see here, there could be 3 alpha hydrogens here, 3 alpha hydrogens here, 3 alpha hydrogens here. So total 9 alpha hydrogen. This corresponds to 9 hyperconjugation structure. Similarly, here is 1 alpha carbon, 1 alpha carbon. So I would say 3 alpha hydrogen, 3 alpha hydrogen. So total comes to be 6 alpha hydrogen. So 6 hyperconjugation structures. Here in this case, there is only 1 alpha carbon, so 3 alpha hydrogen. So I would say 3 hyperconjugation structures. So more the hyperconjugation structure, more is the stability. So I would say the stability is of the order tertiary, then you have a secondary, then you have a primary, and then you could have a methyl radical which does not contain any alpha carbon or alpha hydrogen. So this was about few examples of hyperconjugation. Similar hyperconjugation could be explained in many other compounds, right? So in which there should be an alpha carbon and alpha hydrogen should be present. This was about the section on hyperconjugation effect. This is basically the final part of the electron displacement or the bond displacement effect. Now, the next is reverse hyperconjugation effect. Okay, so what exactly is reverse hyperconjugation effect? This effect is normally observed in the case of, so if you could see this is the alpha carbon. So this is observed in the case of alpha halo compounds, right? So alpha halo compounds. So what exactly happens? So in this case, the delocalization of electron occurs towards the halogen group. So what exactly happens? You get the first hyperconjugation structure. So you have Cl, C, and then you have a Cl, then you have a double bond CH, single bond CH2. Now this carbon has lost this electron. So it gets a positive charge, and then you have a Cl with a negative charge. So in this is basically what you call it as reverse hyperconjugation, when the delocalization of electrons occur towards the halogen atom. So in this case, I would say the delocalization of electrons occur towards X atom. Okay, this is what you call it as reverse or opposite of hyperconjugation, reverse effect of hyperconjugation, called as reverse hyperconjugation. Okay, so this is one of the phenomenon which creates an argument about the dipole moment in the case of alpha halo compounds like this. Okay, so this was about the section on reverse hyperconjugation. It is normally observed in the case of alpha halo alkene. Okay, so this is basically alpha halo alkene. Now the same thing would be observed even when these two chlorines are replaced by hydrogen. So it could be something like CH2Cl, and then you have a CH double bond CH2. So this contains 2 alpha hydrogen. You could have something like CH Cl Cl, and then you have CH double bond CH2. So reverse hyperconjugation effect would be operating in these compounds as well. Okay, so it need not be just chloro, it could be bromo, it could be iodo, it has to be an alpha halo alkene.